Hello and welcome once again to Interesting Stories in the History of Diagnostics. This is Mickey Urdea for Altaris Associates. And today I'm going to talk about hepatitis C. I'm going to talk a bit about the history of hepatitis, the history of hepatitis C in particular, and then the activities that went on at Chiron Corporation over the course of several years during the discovery, the development of the first diagnostic test, and some of the ramifications of that. And then in our next episode, I'm going to go much deeper into all of the things that transpired after this discovery with regard to viral load testing, antiviral drugs, and where we are today. So hepatitis as a disease has been known for centuries. It goes all the way back to Hippocrates, as a matter of fact. And it's as it ends up, a series of diseases, but hepatitis in general is characterized by jaundice, which is usually either yellow skin and or yellow eyes. It can lead to fatigue, to stomach aches, to diarrhea, and often discolored, usually very dark-colored urine or light-colored feces. One of the major routes of infection, which I'm going to focus on today, is through blood transfusion. And this has been a problem for a very long time, ever since blood transfusions were implemented. Over the years, we've come to realize that there are several different hepatitis viruses. The first two that were actually isolated are actually hepatitis B, which was isolated in 1965 by Barak Blumberg, who's actually at the Rockefeller University. And then in 1979, hepatitis A was discovered. After those two were discovered, it led to a series of blood tests where people are looking for antibodies against either of those viruses as an indication of the presence of those viruses within blood. And that then led to the ability to actually call out the units of blood that were infected with those two viruses. But even after they did that, there was still a substantial amount of hepatitis infection, which was believed to still be caused by transfusions, which suggested that these tests alone weren't actually adequate. As a matter of fact, there was belief that there was at least another virus that was involved, and it became known as Non-A Non-B. Very interesting, and often referred to as NA-NB in literature. This led to what became an international effort to try to isolate this new virus. And it wasn't as easy as the first two. As it ends up, one of the major reasons was there was a lot less of it in blood. One of the major people that was an advocate of this and working very hard at it was Harvey Alter, who was at the NIH. And Harvey had been working for years on two different forms of this non-A non-B hepatitis, one in humans, of course, but also in chimps. And as it ends up later, those are the only two animals which are actually naturally infected with that particular virus. Harvey had isolated a series of samples from all over, including the chimp samples, but also from humans, where he set up a blinded set of samples that he would provide to people who thought they might have come up with a way in which to detect that. I'll come back to that, which is rather interesting in and of itself. Now, Chiron Corporation enters into the picture. As many of you may know, Chiron started in the 80s, in fact, in 1981, and it started with Bill Rutter, Ed Penhote, and Pablo Valenzuela. Ed at the time was at UC Berkeley, but Bill had a large lab at UCSF, where both Pablo and I were postdocs. And a lot of the work going on there had to do with hepatitis B and attempts to clone different proteins within it and express them with the hope of actually creating a vaccine. That work was then transferred from UC San Francisco to Chiron with the university's permission and continued as a collaboration with Merck Corporation in order to create a vaccine. And that, in fact, did lead to the first vaccine for hepatitis B. Hepatitis was in the blood, if you will. And so it was logical for Chiron to start getting into the discovery process to find this new virus, this non-A non-B virus. So Chiron reached out to an individual named Michael Houghton, who at the time was at Cyril Research Laboratories in the UK. And Mike had presented a number of papers on work he was doing in the genetics of interferons. And he was using a method referred to as complementary cDNA libraries or cDNA libraries. And I think people believed that would be a particularly useful approach in trying to clone this non-A non-B virus. So it ended up that Michael was being courted by Amgen as well to join that company instead of us at Chiron. And Pablo managed to convince Michael to come to Chiron instead, which was wonderful. And he formed a research group that was composed of Huilim Chu, Keng-Sheng Wang, and Amy Weiner. And later in 1985, George Kuo, who ends up being a very important part of this whole story, joined the company as well. and he formed an antibody research group that was focused on diagnostics and a lot of other applications that becomes critical in the story. Oh, and by the way, our Rich Thayer actually participated in this team as part of the DNA sequencing lab that provided DNA sequencing services to Michael and his group. Now, I mentioned that hepatitis B virus was discovered back in 1965, and that approach involved using a blood sample. In fact, one particular one referred to as the Australian antigen sample that came from an Australian Aborigine that was infected with hepatitis B. And they then used a serum sample from a patient that had hemophilia, who had been infected, unfortunately, with hepatitis B in transfusion. So people knew that this existed. There actually been pictures of it shown in electron micrographs, but nobody had actually cloned it and been able to sequence it. So the sequencing came later, but they actually discovered the presence of the virus itself in the samples using this approach. So that was very helpful. But in contrast, Michael and the group wanted to do this a different way. What they wanted to do was to take the cDNA libraries made from RNA, DNA, from tissue samples and blood that were acquired from both chimps and from humans that were infected with this new virus, this Non-A Non-B virus, and they got samples from the CDC in the United States. Over the next 3 years, Michael and his team spent a lot of time, an enormous amount of time, in fact, almost 24/7, screening tens of millions of clones with these cDNA libraries, looking for the nucleic acids that would likely have come from this unknown Non-A Non-B viruses. But they kept running into host sequences. So there was nothing that showed up that appeared to be this virus. Very disappointing, although they worked remarkably hard at doing it. But in 1985, George Kuo suggested a different way to approach this cloning exercise. What George suggested was what's referred to as a blind immunoscreening. What George had in mind was to actually produce recombinant proteins from the nucleic acid samples that were collected from tissue samples from people that were infected with Non-A Non-B hepatitis, and then to use antisera from patients with Non-A Non-B to see if antibodies would light up these proteins. You would not expect there to be antibodies against the host proteins, which is most of what these clones were likely to be. But if they were actually viral proteins, you would expect that you might find antibodies in people that were infected. So this approach was considered a pretty high-risk approach. As a matter of fact, in an article that was written in Nature America in 2005, they have this quote, which is, "A scientific fishing expedition in which researchers weren't sure they had either fish or bait." So this sounded a little odd to everybody. So there were a lot of skeptics at Chiron about whether or not this approach would work, since the last approach with the cDNA libraries hadn't yielded anything since 1982. It's been 3 years now. And will this new one work any better? So the very interesting thing that happened, and this is the story that I don't think many people probably heard, but what happened was that our vice president of diagnostics, Lacey Overby, had a really great suggestion to Michael, which was, is there some other virus that you could actually test this on that might be a lot easier to clone and sequence? And in fact, it wasn't another hepatitis virus called hepatitis delta virus, also called hepatitis D virus. And in fact, some people say it's really a subvirus, but that's another story. But nevertheless, it was believed that this was a much higher concentration than would be Non-A Non-B virus. So he and his team actually embarked upon that. And very rapidly, they were able to use this blind immunoscreening approach. And Michael and team were able to sequence and clone the virus using this approach and published it the very next year, 1986. I got to tell you, from that point forward, the skeptics were on his side. So they moved forward. So just a year after that, 1987, Michael and team actually found the clones that were believed to be Non-A Non-B hepatitis. They worked very hard to complete the cloning process. If you're familiar with this, usually you find a piece of it with these first clones, and then you're looking for additional clones to expand the overall sequence of the virus. And they finally did that. Were able to find it was about 10,000 nucleotides long. It was a flavivirus, positive RNA strand virus, and we're off and rolling. So the next thing they really focused on was using some of the clone proteins from this virus and to create a screening test, a blood screening test, to deal with this transfusion problem. So George Quo and his antibody team jumped on that, worked together with Michael's team, and came up with this test pretty quickly. In fact, they had enough confidence in it that the next year, 1988, that George Quo gave a call to good old Harvey Alter. Now, I wish I had been sitting there watching Harvey when he heard this call from George, because he'd got a lot of calls like this before. And I remember hearing him in a quote say, well, none have broken the code yet. It's been virus 20 and researchers 0. So, he was not expecting a lot from this. But in fact, he sent the samples out. The team worked through this over the next several days. He got the results back from them and looked at the code. Remember, these are blinded samples, and they got all but 2 of them. And as a matter of fact, over the next several weeks, they were able to show that the other 2 reacted as well. So, home run. And over the course of the next many months, the team got a number of other samples from researchers all around the world that similarly had been collecting them for some time and knew which ones were positive and which ones were not. And the test worked remarkably well. In May of 1988, there was a seminar at UC San Francisco where it was announced that Chiron had cloned this Non-A Non-B virus. In a similar time frame, Ed Penholt was at an investors meeting where he had announced that this cloning had occurred, which was big news. And he said, we're calling it hepatitis C for 2 reasons, right? So it was C virus in order and also came from Chiron. So that name caught on, not because it was after Chiron, but it caught on and people started calling it hepatitis C from that point forward. 2 major papers appeared in the April 21st issue of Science in 1989, and they really did lay out the entire story from beginning to end. It was really a well-done, well-documented, remarkable event. And as a matter of fact, Harvey Alter, who's always good for a great quote, said of this whole thing, Michael Houghton proved the principle that you can find viruses that you've never seen, that you could not test for, and that you could never culture. So that was actually the case. In all these other cases, the hepatitis A virus, hepatitis B virus, people had actually seen, in some cases, been able to culture. They had the virus, but not in the case of non-A non-B, not in the case of hepatitis C. This was really quite a remarkable event. In 2020, Michael Houghton, Harvey Alter, and Charlie Rice received the Nobel Prize for the work in hepatitis C. Charlie had been working on a means of actually culturing hepatitis C virus in media, which people have been trying to do for years, but had not been successful with. And that had a lot of impact on the ability to screen drugs and do a lot of things going forward that had not been possible before. Chiron partnered with Ortho Clinical Diagnostics, a division of Johnson & Johnson, to develop the first blood screening assay to be used in screening blood for transfusion. And that was approved in Japan and in Western Europe in 1989, and then in 1990 was approved in the United States. By 1992 in Japan, the level of hepatitis infection as a result of transfusion had been decreased by 75% in a very short period of time. An interesting side story I thought I'd relay. In 1988, in Japan, non-A non-B was a serious source of infection still from transfusion. About 18% of units were contaminated and infected the person that they were transfused to. There was no test to screen that, so there was no way to prevent it. At this time, Emperor Hirohito was actually suffering from intestinal cancer, and he was receiving frequent transfusions with these units. So, as you might imagine, his physicians were very concerned that with this frequent transfusion, his chances of getting hepatitis non-A non-B at that time was very high. So members of the Japanese Red Cross actually contacted Bill Rutter at Chiron and said, would it be possible for us to get access to this experimental, because it still was experimental, ELISA assay that we could use for screening? And of course he agreed to that, provided them to them. They used it in screening units for transfusion to the emperor from that point forward. Unfortunately, the emperor did pass away the next year at age 87. But the Japanese authorities were so very grateful that they were extraordinarily helpful in approving the commercial assay that J&J and Chiron had developed for blood screening in the general population in Japan. As I mentioned, that approval was in 1989, a year before the approval in the United States. I hope you've enjoyed hearing a bit about the history of the discovery of the hepatitis C virus and the work that went on shortly after discovery to develop the first test that was very high impact. And that was, of course, the test for screening for the presence of antibodies in human blood to prevent the occurrence of hepatitis C infections from transfusions. Very big step forward. Next time, I'd like to talk more about what happened after that discovery and what happened after the introduction of that first test. Many more tests were developed. The work that was done to create the first antiviral drugs, the impact that diagnostics had on that, including the viral load test that my group worked on at Chiron, and talk a bit about what's transpired since then. It's been an explosion of activity for decades now, and I'd like to talk a bit about where we are with regard to potentially even eradicating hepatitis C throughout the world. Thank you once again for listening to another episode of Interesting Stories in the History of Diagnostics. This is Mickey Urdea for Halteris Associates. I look forward to talking with you next time. Goodbye.